welcome to the deep dive. Today we're looking at Mars, specifically Jezero Crater, where the Perseverance rover is right now.
That's right.
We always thought of it as this ancient lake site, basically. But there's a new article suggesting something else was going on too. Volcanoes.
Yeah, quite a surprise.
So our mission today is to sort of unpack this. How does a hidden volcano, Jezero Mons they're calling it, maybe change how we think about early Mars? And crucially, the potential for life back then.
Exactly. I mean, the whole reason we went to Jezero Crater was the water story. Billions of years ago, definitely looks like a big lake, a river delta. We're talking maybe 3.8 to 3.5 billion years back.
Okay.
And the thinking was, those sediments packed with clays, that's where you look for signs of past life, if Mars ever had any.
Right. So the primary goal was water, water, water. Find the biosignatures in the lake bed mud.
Yeah.
But Perseverance lands, starts looking around, and finds, well, not just mud, it found something hotter.
Precisely. It confirmed the watery past, absolutely.
Uh-huh.
But it also found igneous rocks, rocks cooled from lava.
That was the first clue. Volcanic stuff happening right there in the crater. And then, looking closer with high-res images, that big peak on the edge, Jezero Mons. It looks like a composite volcano.
A composite volcano. So like built up from multiple eruptions over time.
That's the idea, yeah.
Wow, a volcano. Right where we thought it was just, a peaceful old lake. That kind of flips the script, doesn't it?
It really does.
So can you picture it? Molten rock flowing into this ancient Martian lake. Did we actually find signs of that happening, like evidence of them mixing?
Well, yes, we think so. There are features, geologically speaking, that look like channels carved by lava flowing into the lake water. And maybe even more telling is the mineral analysis. Spectroscopy, it picked up this mix of olivine, magnesium carbonate, hydrated minerals, pyroxene.
So break that down a bit. Olivine is volcanic, right?
Very common volcanic mineral, yes. But then you also have hydrated minerals and magnesium carbonate. These often form when olivine reacts with water. So you've got the volcanic signature and the water signature kind of reacting together in the same place.
That's what the combination strongly suggests, yeah. Fire and water coexisting.
Okay, so fire and water together. And what does that mean for life? Because that's the big question here. On Earth, volcanic heat, hydrothermal vents, they support life. Could Jezero Mons have done something similar?
That's the really exciting implication. Think about it. Mars was cooling down, losing its atmosphere maybe, but if you have volcanic heat...
It could keep things warm locally.
Exactly. It could have kept pockets of liquid water around for much, much longer. And not just warm water, but water enriched with minerals from the volcanic activity.
Like those hydrothermal vents deep in Earth's oceans.
Sort of analogous, yes. These could have been stable niches, protected perhaps with the energy and the chemical ingredients needed for life's building blocks. Maybe even for simple life itself to get started or hang on, even when the surface got harsh.
So these little potential oases powered by the volcano while the rest of Mars was freezing over, that's a pretty different picture.
It is. It suggests habitability might have persisted longer or been possible in different ways than we first assumed just based on the lake itself.
Okay, so Perseverance is sitting right there collecting samples. These samples are the key then to figuring out this timeline and what really happened.
Absolutely critical. The plan is to bring those samples back to Earth eventually. Here, we can do really precise isotope dating.
To get exact ages for the rocks.
Yes. Find out when the volcano was active compared to when the lake and delta formed. Was it before, during, after? That sequence is hugely important.
Right.
And just analyzing the composition of those rocks in detail from the volcano's flanks, from the crater floor, could tell us so much about the actual conditions back then. Was it truly habitable?
And I guess this isn't the only shot we have at understanding this. There are other missions being discussed.
That's right. ESA, the European Space Agency, they've proposed concepts like Lightship and Spotlight. These could give us even more detailed remote sensing data of Jezero. And then way down the line, you have the possibility of astronauts actually going there, doing field work on those volcanic layers.
Wow. Okay, so the big question that this article raises really is, does this hidden volcano fundamentally change the story of life on Mars? It feels like the potential answer is yes, maybe?
It certainly complicates the story in a fascinating way. It suggests early Mars was potentially more geologically dynamic in places like Jezero than we maybe gave it credit for. It wasn't just a watery world, but potentially a world of fire and water interacting.
And that interaction Might have been key.
Could have been crucial for creating or sustaining habitable conditions.
Yeah. So a final thought for you listening. Think about that interplay, volcanic heat, liquid water.
Yeah.
Maybe that combination, those geological forces working together, isn't just a Martian thing or even an Earth thing. Maybe it's a more universal recipe, for getting life started wherever the conditions allow across the cosmos. Something to chew on.